Hello everyone, welcome. Have you ever wondered how Google serves billions of users on apps like Gmail, Photos, and Maps?
Or how about the viral YouTube video Soda Pop from the movie K-pop Demon Hunter? For those of you who have kids know exactly what I'm talking about. Kids were and still are addicted to it. How is it possible for millions of kids to start watching Soda Pop at the exact same second across the globe without the video stuttering or the services failing? That low latency, high availability experience is the result of some awesome invisible engineering magic behind the scenes. Hi, I'm Neha. I'm the Database Specialist CE.
I'm Rakesh, an Infrastructure Modernization CE. We are here to talk about the magic that helps Google run its greatest services. Before we talk into this magic, let's look at our database offerings. So all the way on the left side of this picture, you will see some of the very popular database engines which are offered by Google Cloud. On the right side, you will see some of our own database engines. And Spanner, the hero of today, sits right in the middle there. It sits right in the middle of relational and non-relational databases. It has a support for key value offering as well with our Cassandra API. All these databases are built for developing state-of-the-art GenAI applications. All of these databases does support vector search, and our Vertex AI platform, along with LangChain support, gives you a very good ecosystem to build your GenAI apps. So today we are going to cover a few topics. We'll look at the Spanner as a database, and then we'll look at how it integrates with BigQuery. We'll look at Spanner under the hood, how to use it, and then we'll go into some migration tooling. Let's start with the basics. For decades, the operational databases have been the undeniable hero sitting right at the core of our business applications.
Precisely. And for years, this structure has served us very well, where the database is the ultimate brain of the operation. Then you have the front end. That's the cool exterior, the slick UI that users interact with. And then you have the middle tier, the hard worker that handles the business logic, until the internet decided everything had to be instantaneous and global.
Look at this. This is a great slide, but it is a hairball. We're trying to scale up, and we realize that the increasing costs, and we will hit soon the physical ceiling. So it's like buying bigger house until we realize there is just no more land left to build anything, right? But then we can try replication. But what is the problem with replication? It adds more complication for HA operations and also difficulty in scaling and updating these replicas. So that's where eventually it will lead to an inconsistent state. Eventual inconsistency is what we're talking about.
Eventually inconsistent. A polite way of saying, I have no idea what the right number is right now. And don't even get me started on sharding. Sharding is where you break the database into pieces, and then we just kind of pray and hope that they still talk to each other correctly. And the final boss, active configurations. High availability, yes, of course, but you get stuck dealing with the complex conflict resolution and even more complicated HA operations. So basically, we're either hitting a wall, losing consistency, but what if I tell you we could skip all this drama?
That's where Spanner steps in. We said that scaling, operations, maintenance are the challenge, but Spanner flips the script. Spanner handles relational and non-relational workloads seamlessly. And remember, all those HA complications we discussed in the previous slide. With Spanner, you get zero-touch maintenance and high availability. It's always on.
Zero-touch maintenance, exactly. That will definitely help the operations team. And the consistency challenge. So replication made you eventually inconsistent. What does Spanner promise?
Spanner promises global consistency, strong global consistency. When you look at the data platform wheel on the right side, you will see 5 pillars. Strong consistency is one among them, and it also provides high availability and a scale-out architecture. Spanner delivers the performance and the scale.
But what about scaling limits? We talked about physical ceilings.
No problem here, Neha. Spanner offers unlimited read and write scaling with real-time elastic resizing. You literally never run out of room or speed.
Exactly. Elasticity is one of the true hallmarks of Spanner. We often buy way too much database capacity just in case of a bursty workload, which means we're over-provisioning and wasting money most of the time. But Spanner changes that with the elastic provisioning. You only pay for what you need.
How does it know what I need?
Excellent question. Love that. Well, we've got the managed autoscaler. You can configure your instance to autoscale based on usage. And the genius part is that it can asymmetrically scale read-only replicas.
Oh, so on a Black Friday, I don't have to go scramble, panic around, and buy some extra servers to handle the people looking for sales and leave it out there for 11 months to sit.
Exactly. And that's the flexibility that's translating directly into massive cost savings, Rakesh.
There you go. My data footprint is massive. Is there a way to make sure my old data isn't sitting on expensive piece of hardware?
Wow, you're getting some great points there. And that's where tiered storage steps in. Spanner automatically optimizes your storage costs by seamlessly migrating cold data to cheaper storage.
So we are cheaper, smarter about cost, but all that optimization means nothing if it cannot perform. What do you think about speed?
Excellent point. Speed still remains the priority. Spanner is built to help you build the interactive applications with consistent, predictable, low latency, and thanks to the established sub-5 millisecond read-write latencies.
Awesome. I heard the latency is getting better.
You're stealing my thunder. It is getting faster. You heard that right. We're also introducing reduced latency, currently in gated GA, which can reduce end-to-end latencies by up to 50%.
So on this last slide, we introduced Spanner, the superhero for today, right? It gives unlimited scale and consistency. Problem solved, right? Well, almost when we thought the problem is solved. Our developers need something else, right? They said they need more than just relational database now. Modern applications are hungry for context.
Exactly. We need to do things like highly specialized graph queries to see those relationships between users and purchases. Or maybe we need a dedicated text search engine for rapid keyword searches. And now with the buzzword Gen AI, everyone needs a vector database for similarity searching.
Yeah, it sounds cool on paper, but look at the drawing. It's like a hairball. You have a main relational databases, then you have both specialized databases like graph, vector, text, etc.
And how does the data get from the truth, the relational core, into all these specialized systems? It's my favorite three-letter word that haunts every data engineer. ETL, which I call it as endless troubleshooting loop. Isn't that right?
Wow. ETL is not endless trouble-causing loop, but ETL itself is a very big pain. It leads to duplication, data lag, and my personal favorite headache is governance and security drift. Managing security policies across 4 different database stacks is 4 times difficult than any compliance teams would like to do.
So the question, guys, is not just how do we scale relational data? The question is, how do we handle all these new complex data models without turning our architecture into this mess?
Neha, let's look at how Spanner solves this multimodal problem and allows us to consolidate operations, shall we?
Absolutely. So remember, guys, we started with this beautiful picture for Spanner with the 4 foundation pillars. Well, now Spanner is multimodal.
It does support graph queries with our GQL, and also it supports full text search, vector search, and recently columnar engine for your HTAP use cases as well.
And it doesn't stop there. The multimodal Spanner provides a powerful toolkit to build Gen AI first applications. With Spanner search capabilities, users can combine traditional search with semantic search with powerful ranking techniques like reciprocal rank fusion to re-rank results. And as we know, LLMs do better with context. These primitives, along with Spanner's core relational capabilities, allow simple and powerful RAG and graph RAG applications to be easily developed.
Combining all this with Spanner's native integration with Vertex AI for real-time inference and embedding generation gives an end-to-end solution for AI-first application development. In addition, we're happy to announce NLP extensions, which allows users to apply Gen AI reasoning and knowledge to extract valuable insights from not only structured data, but unstructured data as well.
All right, so this is an example of a query that shows that within Spanner, these models are fully interoperable, allowing you to query by simply writing some SQL, no data duplication, and no ETL. As an example, here we have a user that's looking for brown hiking boots. The query starts by finding products whose description matches the brown hiking boots. And guys, we're working within a relational framework. You can see the select over there, so select ID from products. But we've reached a point where standard relational filtering isn't enough to find brown hiking boots. So we seamlessly invoke a full-text search predicate, search, directly within that relational block. Then to augment the traditional key-based approach, we're using Spanner's native Vertex AI integration to generate an embedding of our description, which feeds into a vector search to finally find the semantically relevant results. And finally, these results are personalized by limiting the products to those that our input users' friends have already purchased. So that's your graph query right there. At Google, Spanner and BigQuery are two cornerstones on which billions of user applications are built. And customers are actually finding value to put these products together. And why would we want to do that? For a lot of reasons. You can run federated analytics across the systems using Data Boost. Federated querying is the key technology which allows you to run a standard SQL query in your BigQuery environment that includes a command to read data directly from an external source, which in this case is, of course, Spanner database. And the major benefit is that you can get real-time insights from your live operational data in Spanner and join with the massive table in BigQuery without copying or moving the Spanner data. And this is really crucial for accessing that freshest data for analysis. Now, if you guys are familiar with the analytical queries, it can be very CPU intensive as they they can often scan these large portions of your transactional database, which is why the red rectangle, the beautiful data boost over there, that's our fully managed serverless feature that can provide the independent compute resources and workload isolation where the analytical workload is offloaded to the separate compute pool. Now, the other thing you can do is that it's also available for latency serving, is where insights obtained from data analysis in BigQuery are available immediately on Spanner for low latency serving, such as dashboards using reverse ETL and continuous query support.
We spoke about a lot of good things about Spanner. Let's look under the hood. The top level object in Spanner is called a Spanner instance. So you can create a regional instance, a dual region instance, or a multi-regional instance. And also you can configure the compute capacity and the storage required for your instance directly from our Google Cloud Console. So last year, we started offering Spanner in 3 editions. We have a Standard Edition, Enterprise Edition, and an Enterprise Plus Edition. Enterprise and Enterprise Plus editions will provide you with all the capabilities that Neha was talking to you about. Enterprise Plus offers multi-regional support as well as geo-partitioning in addition to some of those key capabilities. And also Enterprise Plus gives you 5 nines of availability, which are crucial for some mission-critical applications.
Here we see a typical Spanner deployment. So this diagram kind of shows you a regional instance configuration which contains services in 3 zones, A, B, and C, and each zone represents a replica of a Spanner deployment under the hood. So you also see a disaggregation of compute and storage. It is just like BigQuery, which is our data warehouse. Let's break it down a little bit more. So an application services, they speak to Spanner by accessing a public endpoint, which is intercepted and routed by our Google frontends. And then the Google frontend forwards a request to an appropriate Spanner frontend, which is kind of responsible for things like authentication and cloud audit logging. Spanner frontends then interact with the core Spanner compute servers to execute the database operation. And these compute servers in turn interact with the zone local distributed file system known as Colossus to retrieve the process and serve the database results. Colossus, Rakesh, what's Colossus?
It's the same storage that is used by Google, Gmail, YouTube with massive scalability and resiliency for storage.
Absolutely. Same storage for Gmail and YouTube. And all of this is, by the way, happening within a few milliseconds of latencies. Let's take a look at this in detail now. So for any base region configuration, Spanner maintains 3 read-write replicas, each within a different Google Cloud zone in that region. Each read-write replica contains a full copy of your operational database. And each of these zones is an independent failure domain. So let's say if a zone fails, let's say zone 3 fails, and the database still remains available, being served by the remaining nodes. Rakesh, do you know if I should be doing any manual intervention here?
Not with Spanner.
Now with Spanner, that's correct. Once the zone comes back up, it will catch up from the other replica automatically.
Okay, we talked a lot about the features of a Spanner. Let's look at the performance a little bit. Here is the slide with a bunch of QPS, the peak QPS, read and write QPS that is supported by Spanner. Spanner, each node supports up to 10 terabytes of stored data. And also you can configure the nodes based on processing units, which can go as granular as 100 processing units as well. Spanner offers 5.9 availability for your mission critical applications. With high performance comes huge impact. Let's talk about some serious numbers here. Look at the top left, 6 billion requests per second at peak. That's not just busy. That's everyone on the earth refreshing their feed simultaneously busy. And it manages more than 17 exabytes of data. And the speed is what makes it operational. We're talking sub 5 millisecond read-write latencies. This isn't just archiving data, it is real-time, mission-critical performance. Spanner has powered the rapid growth of Google. The same technology runs Google Cloud, Google Workspace, and critical engines behind Search, YouTube, and Android. And it's not just Google's sandbox. Look at the customer logos below. We have massive retailers like Walmart and Macy's, financial titans like PayPal and Goldman Sachs, and security innovators like Palo Alto Networks. I guess the common thread here is that all these companies need massive scale, global reach, and absolute data consistency. And they found that solution in Spanner. Let's see how we can help you get there as well. Spanner offers a migration tool which not only helps you with your data migration, but also helps you with the application migration as well. It supports zero downtime migrations, data validation, schema conversion, as well as with your initial migration assessment.
All right, so we've covered a lot of content. Let's bring everything home. So remember this diagram, and we had our Lindsay developer. She was having issues building this intelligent database application. Say it's an e-commerce marketplace and you want to create an application that will allow users to search for products using keywords or natural language and make intelligent product recommendations based on past searches and related products. Well, traditionally, this developer would have to introduce multiple purpose-built databases into their development and perhaps do some ETL, so that poor developer in this image doesn't look really happy. Let's see what we can do to make her happy, Rakesh. So let's look at how Lindsay could develop this application on Spanner using its multimodal capabilities. On Spanner, adding graph, vector, and full-text search is as simple as a few DDL commands. First, search index on columns are ready in relational database. Gets the advanced NAT language enhancements out of the box. No additional integrations required. Next, the data science team provides the ML model for advanced product similarity matching and uses this to integrate highly scalable and available vector index, just another index. Finally, to model and extract relationships, the users, products, and purchase history are ready in database. Lindsay uses Spanner Graph, and she builds an overlay representation to represent her data graphically, all with no additional storage overhead. With a few simple DDL statements, Lindsay is now set up to build and deploy her end-to-end application, including all the core platform benefits of Spanner, like elasticity and availability.
To wrap up, we have Spanner, which provides you with multimodal capabilities, high availability, and great migration tooling. Check it out for yourself at cloud.google.com and search up Spanner. What are you waiting for? Let's migrate!